G naught f, that can be defined in another way on G naught f. Here we defining only the f naught g. F naught g is defining as that f naught g is f of g of x. Okay. This is a composite function. It is denoted by f naught g and it is defined as f of g of x. That means the function which is defined in g of x, the domain of the domain of the function is the range. The domain of the function f is the range of the function g. Okay, this function is noted as a knot and it is denoted as a knot and it is defined as a f of g of x, and g naught f, if both are defined from R to R, then g naught f equals to g of f of x. Clear? F naught g is f of g of x and g naught f is g of f of x. Now take an example how it will be defined. Let the function f as an example. Let an example f of x, f and g both are defined from R to R. Both are defined from R to R. Then f of x equals to 2x plus 1 and g of x, we are taking such a simplest example, g of x equals to 1 by x square minus 2. Okay. Then f naught g will be f of g of x, that is f of 1 by x square minus 2, and it will be f of 1 by x square minus 2, that means 2 into 1 by x square minus 2 plus 1. Okay, that is 2 by x square minus 2 plus 1. 2 by x square minus 2 plus 1, that is equals to 2 plus x square minus 2 by x square minus 2, that is x square by x square minus 2. Clear? And by this process you can find the g naught f also. This is the composite function. You have to find the both of f naught g and g naught f. You can also distinguish the function, composite function f naught g is not equals to g naught f. Yeah. That's next one, fourth one is more important from the last three. That is the inverse of the function. Okay. That is the inverse of function. Inverse of the function, first of all, D is a subset of R and f is a function from G to R, where D is the domain and R is the range. And f of D, the domain of the function, that is the range of the function, is E. Okay. If E is a proper subset of R, then the function has to be injective and also surjective. Then we can find the inverse. Okay. If the function is only injective, not the surjective, then we couldn't find the inverse of the function. Okay. Inverse of the function is defined by this. We already known about the sign, and that function is f is surjective and also injective. Then we can find the inverse property or the inverse function. Alright. How it is defined? If the function g is another function which is defined from e to d, then if g of y equals to x, that is a function reversely defined from the function e to d, then g of y equals to x. If it is g of y equals to x, then we can say that f of g of y equals to y, or g of f of x equals to x for all x belongs to d, and for all x belongs to for all y belongs to e, then this g is said to be the inverse of the function f, and it is denoted by f inverse. Then g is said to be inverse of f, and it is denoted by f inverse. Okay, that is a function from d to r, a function a from d to r, where d is a subset of r and d is the domain of the function, and f of d, that is the domain of the function, is e, which is a proper subset of r, that is the surjective property. Okay, then we already mentioned that f is a surjective and both is surjective and as well as a injective. Then g is a function, g is another function. How it is defined? G is a function which is defined from e to d by this process, g of y equals to x, then f of g of y equals to y, that because f of g of y equals to f of x, that is y. We already defined f of x, f of x equals to y. Okay, if f of x equals to y, then g of y equals to x. Here we define that g of y equals to x, then f of g of y equals to f of x, that is f of x equals to y. Therefore, and g of f of x equals to g of y, and g of y equals to x. How the function is defined? G of y equals to x and f of x equals to y. Therefore, we call g is said to be the inverse of the function f, and it is denoted by f inverse. Okay. First of all, you have to note that a function, how is it defined? F is defined. Inverse function is such a critical function. Okay, you have to first in mind that function will be of both injective and surjective, Now for the function f of d, the domain of the function is e, which is a proper subset of r, and g is a function which is defined from e to d. Okay, that is a e is a subset of r, proper subset of r, e to d. How is it defined? That is defined by g of y equals to x and f of x equals to, first of all we already defining that f of x equals to y and g of y equals to x. Therefore, f of g of y, that means g of y equals to x, that is f of x equals to y. Okay, clear? And g of f of x equals to g of f of x, that is y, that is g of y equals to x. We already mentioned here, that is the composite rule. Okay, we are using here the composite rule. That's why we are already discussing about the composite rule. Okay, the g of f of x equals to g of y, that is x for all x belongs to d, and here the for all y belongs to e. Then we call that g is said to be a inverse of the function f, and it is denoted by f inverse. Clear? Okay. Now we have to take some example. Example. Okay. D as if x belongs to R such that x greater than 0. Greater equals to 0, we can define that. We can take that x greater equals to 0. That means the positive real numbers with including 0. Okay. F of x equals to, f of x is a function which is defined from d to r. Okay. And f of x is a function, that is f of x equals to x square. Such an easy example, that is a square function. And we are taking y. Okay, what is the inverse of the function? That is f of x equals to x square. Where x square? That is this. And g is the inverse of the function. Then it will be g equals to f inverse. F inverse equals to, that is x square equals to, we can take that x square equals to y. Any number or any number from g. Then x equals to root over of y plus minus y. Because we are taking only greater equals to 0, that means we are taking only plus 1. Okay. Therefore, g equals to f inverse of y. F inverse of y. We can also take that f inverse of x. That is equals to root over of x. Clear? Therefore, if f of x equals to, if f of x equals to x square, then f inverse x equals to root x for x greater than equals to 0. For all x belongs to R. Clear? Okay. Now, our second last topic is some algebraic property of the function. Algebraic property, that is a last 6th number property, that is a algebraic operation. You can say that operation, also the property. Okay. If D is a subset of R and F is a function from D to R, if f is a function from D to R and g is a function which is also defined to D to R, then first property is summation f plus g. Okay, f plus g of x, we already know that f of x plus g of x. Okay, f of x plus g of x. Second property is subtraction property, or you can also use f minus g, where f minus g equals to f of x minus g of x. Okay. This is summation function, or you can say that this is a subtraction of the function. The product of the function f dot g of x, it can be used as f of x into g of x for all x belongs to D. For all x belongs to D. Third property is something k belongs to R, that is a k something scalar number. K into f of x equals to f k dot. Okay, k dot f of x for all x belongs to D. That k is a number from R, then k of f of x equals to k dot f of x for all x belongs to x. Here, the last property, not the least property, it is the, you have to know that if g of x not equals to 0, then the quotient function f by g, the quotient function f by g defined by f of x, f by g of x is defined that f of x by g of x. F of x by g of x, where g of x not equals to 0. Clear? Now take an example for some function. For some function we are taking f of x equals to x and x square, and g of x equals to x plus 2. Then f plus g of x equals to x square plus x plus 2. First example. Second is f dot g is equals to x square into x plus 2. Third property is k into f of x, that is k into x square. By the fourth property, f by x, that is x square by x plus 2. Here we are taking the two function fx and gx, and by these two function we already discussing the four algebraic operation, that is f plus g, and it also be f minus g, that is x square plus x minus 2 also. That's it. Okay. If this product property, that is f dot g equals to x square into x plus 2. With the real number multiplication, that is k into x square, and the quotient function f by g equals defined by x square by x plus 2. Okay. Now the last topic is, that is the seventh topic, is monotone function. There is a two type of monotone function. One is monotone increasing and another is monotone decreasing. If first of all you have to define a function f d to r where x1 comma x2 belongs to d, where x1 less than x2, if implying that f of x1 is less than equals to f of x2, then it is a monotone increasing. That is, if x1 is less than from x2, here f of x1 is less than from here f of x1 is less than equals to from f of x2, then it is a monotone increasing function. Okay. If it is strictly less than, then we call this is a strictly monotone increasing function. And another one, if x1 less than x2, implying that f of x1 is greater equals to f of x2, then we call this is a monotone decreasing function. Okay, there is a two type of monotone function. First of all is a monotone increasing function, and second one is a monotone decreasing function. If we there is a distance less than equals to, then it is a monotone increasing function. You see, if we remove this only strictly increasing, then we call that it is a strictly monotone increasing function, and this is a strictly monotone decreasing function. Okay. Okay, class, there is an end. If you have any problem, then discussing with me, give me a feedback. I'll try to recover it. Okay, thank you.